What's up, YouTube? This is T McBlack as YouTube here. What? For those who, if you want to know all about account calculus, for those having trouble with account calculus, it could be like a little miniature account calculus tool here. So, give me a moment. Okay. Just say, hang. My apologies if I don't exactly have like merch up yet. And don't exactly got on the merch link it can buy yet. And basically like a little miniature new movie. And the reason why my mastery of calculus is so important, or is it and you're gonna be if you're going to be an engineer, you're going to be using calculus a lot. I know it was different. That your questions is basically going to be your education. Plus, you might want trigonometry. So I'm going to basically review some basic trig. So here. So okay, hey, we basically So okay, to show all you want me. And how we start off with some trigonometry. I'm going to probably draw you a right triangle here. Sorry if it's not exactly a perfect right triangle. Oh, and you have to know that this here is basically this here is basically the hypotenuse of the triangle. Oh, this here is basically Greek is basically a Greek letter that we use in which we call that theta. Let's say this is 3, 4, and this is x. So the way you're gonna evaluate for that angle here is that you're gonna use Pythagorean theorem in which that's a squared plus b squared equals c e squared. It's adorable. So anyhow, we're gonna state 4 squared is 16 plus 3 squared is 9, and that's gonna equal c squared. You add these up, and once you take the square root of 25, radical c e squared. Is flat over. C is going to equal 5. So this side here is going to be 5. So, all right, back to the trig. So here, this is, we're going to state this here. This here is the hypotenuse. We're gonna call for theta here. We're gonna call this side opposite. Because it's basically this side is basically far away from theta. And for this side, we're gonna call that side a j. A set and degree equal theta, and we're gonna call this side because it's close to angle theta, and we're gonna call this side our hypotenuse. So a little bit of intuition, and opposite over hypotenuse is gonna be sine theta. Sine theta is gonna be the opposite over hypotenuse, which is gonna up over hypotenuse That's gonna equal 4 over 5. I've 10. Okay. Cosine theta is going to be adjacent over hypotenuse. And that's going to equal 3 over 5. And tan theta is going to be the opposite over adjacent. And that's going to be E4 over 3. Okay. Hey, so for those who are wondering, what would happen if we were to divide sine theta by cosine theta? The reason what we would get is that sine theta over cosine theta would equal tan theta, because if we were to basically divide these two, the phi square basically can't cancel out. And you have to know that trigonometry is very useful because it helps us to find the messy side and for a triangle. Plus, it can also help to find the missing side length of an angle over an angle theta. And you ought to know that calculus is you can't use degrees. It's basically radians only in calculus. Yes. So the way you're gonna convert from radians to degrees is that one rate is basically 1 radian and is equal to 108 degrees over pi. It's basically 180 degrees over pi. High degree is 180 over pi degrees. Yeah. Yes. So then 1 degree in radian is gonna be equal pi over 180 radians. Okay. Hey, kind of like basic introduction, and you seriously need to know how to do trigonometry well, because you're gonna be you throw a lot that you're gonna be encountering lots of trick. It can calculus a lot. So, all right, let's go over some basic limits. So let's say we have I'm gonna start out with a graph here, in which we're gonna basically have like a parabola here. Okay, I'm gonna label my axes. X, Y is gonna be 1. Oops. 1, 2. Wait, 1, 2, 1. So, alright, basic intuition. What's gonna happen? So, let's say okay. We basically have our graph here, and for what limit it is, let's say if we were to basically be approaching the graph from this side, here, and we want to know what this equals to if we were to basically approach it from here. So let's say we are always going to be getting closer and closer. So we get closer and closer to that point here. here, and the way it will work out is that we will state limit it on the graph have is limit as x approaches 1 on of graph f of x is going to equal 1. And the way it sorry. I'm just gonna label this as f of x. So what we're gonna do in order for this limit to exist is both the limit for both as we both approach the graph from both the left side and the right side must equal each other. If they do not equal each other, the limit does not exist. Yes, let's say and I'm just gonna wrap it up here. Sorry if I'm a little bit socially awkward. I'm gonna stick to hold. Probably in my next touring video, will probably go into a little bit more or depth with it. And probably review a little bit more of trigonometry. Later. Oh, don't forget to subscribe to my channel. Later.